All right, so I'm going to start a new series where I go over different algorithms, sorting, searching, and all that. And I'm just going to start out with like the bare bones simple algorithm, right? So I have linear sort right here. I'm going to go over, I'm going to go kind of fast, hopefully. And I don't feel like there's too much to break down with this type of sort. Um, what's important to know is that this sort has a big O notation of n squared, which means it's going to be terrible for large data sets or even medium-sized data sets. And so while it's simple to implement, unless you're just using something really simple for a small data set, I would implement something else. We're going to go ahead. So what a linear sort is, as you can expect, is we go linearly through the list here, checking each index at a time, right? All the way through. So what we would do is I would go ahead. I have a random array of, not random, but I just typed in, I populated an array of integers sorted by no order. And so what we would do as the computer, this is the steps that we're doing. We start out at index 0 and we take this number, okay? So we take list I, we compare it to list I plus 1, the number on our right. If the number on our right is less than the number we are looking at, we want to swap them, right? And then same thing. We keep going. We would increment our index every time and we would swap, right? Okay. And we swap. We would keep going until we reach, right? I would keep going. I would keep going. Okay. And then at this point right here, this number is not greater than the number on the right. So we keep it there. And then we keep going with these new numbers and these new numbers. It's pretty simple. The way I'm doing it sorts ascendingly, so the 1 would be on the left and then the largest number on the right. We could also do it sorting descendingly, but we'd have to just change the direction we do it in, right? Instead of larger than, it would be less than, so forth. The way that this function works, because it's in 2, so what we do is after the first iteration, the biggest number will be in this right slot, right? In the second iteration, the 2 biggest numbers will be in these 2 slots. The third, the 3 biggest numbers, 4, 5, 6, 7. And so it will always take, unless you're in the worst case scenario, it will take for something like this where we have 32 integers, we will have to run through it 32 times. But then we're also running through it 32 times each time we do it. So that's why it's n squared. So it's quite intuitive. I'm going to go ahead. I'm not going to break too much down because we're here for the sorting algorithm. I'm just going to declare my size, and I could do this in a number of ways, but I'm going to go ahead. I'm going to use my size of operator to get the size of this list, which would be 32. 32 times 4, because an int has 4. There's 4 bytes representing it. And then we're going to divide it by 4 bytes. So list 0. And this works for any data type. I'll just get you a integer size of. Now that we have that, we can start looping through. So I mentioned that we have to do this in squared times. So intuitively, you could just start out with a 1 for loop. I'm going to skip that step and we're going to use 2 right away. So int I equals 0. I is less than size, I plus plus. Okay. And that's just our first one, right? Where we're going through everything. Then we're going to do another list. We're going to go for int j equals 0. J is less than size of minus 1. And j plus plus. The reason we do size minus 1 is because, right, we're checking the number to our right. If we were checking the number to our left, we'd have to do size plus 1, whatever. But if we were to be on the last index here, and we were to check 1 over to the right, we'd be stepping out of bounds, which we don't want. So we want to stop our search that actually swaps them right here. It will give the same effects, but without going out of bounds. So what we want here is we're going to add a temporary variable. We're going to check, first of all, if index I, or j, sorry, is larger than index j plus 1. So if list j is larger than j plus, sorry, list j plus 1. Then we want to go ahead, we're going to make a swap here. So we're going to make a temporary variable. We're going to set int temp equal to list j plus 1. And then we're going to set j plus 1 equal to j, list j. And then we're going to go ahead and set list j equal to temp. And so all that's doing is saving the variable, setting, or saving this variable, and then kind of swapping them around like this. It's pretty intuitive. And suddenly, I mean, this is all we need, right? Each one of these, each time you run this, it's going to get the biggest number to the right side. It's going to carry one number over to the right side, and it will slowly sort all the other ones, but that's not too much importance. So what I can do is I'm just going to go ahead and print these off. So, all right, so I went ahead and I added for loops to print out every variable in the list. And as you can see, the first list before we did any sorting is completely unsorted, right? It's just a jumble of values. And then after that, we have our sorted list right here, and it's sorted ascendingly. The largest number on the right side and the smallest number on the left side. Anyway, that worked really well. It was really simple. You're probably not going to be using it too much if you're looking for efficiency. Though it doesn't take too much memory, but that is a repeating theme. In general, you have to choose between a trade-off, right? You either want low memory usage and slower algorithm, or high memory usage and faster algorithm. Whatever the fact, we'll probably see that throughout the series. And if you want to watch more, you can subscribe, or you don't have to. Whatever you'd like. I hope you learned something though. And I will see you guys next time.